Hello everyone, welcome back to Spectrum classes. In this video, I am going to solve few numerical problems based on Beer-Lambert's law. So the first problem is find the relative amount of light that gets absorbed by the sample if the absorbance of the sample is 2 at a particular wavelength. So we fix the wavelength and at that particular wavelength, the absorbance is 2, which is unitless quantity, and it asked me relative amount of light that absorbed by the sample. So that we have to find out. So simply first I put the formula, which is equal to absorbance is equal to log base 10 I naught upon I. This is in positive terms, is equal to epsilon Cx. So here it doesn't give epsilon or molar absorptivity coefficient. It doesn't tells us about the concentration and path length, and it simply asks the relative amount of light. If this is not given, then we are stuck to this point only. So absorbance is equal to log base 10 I naught upon I. So I put the value of absorbance, which is 2, is equal to log base 10 I naught upon I. If I remove this log base 10, then what should I do? So the base value will, this left hand side will be the power of this base value, as we did in the previous video. So here 10 raised to the power 2 is equal to I naught upon I. If you simply relate this 10 raised to the power 2 is 100, and if you simply find the relationship between this, then I naught is 100 and I is 1. Here I have written, right? So the amount of relative intensity, how we are going to get that? So relative intensity, how much is absorbed? Absorbance, how we are going to determine this? This is transmitted, this is incident, and the difference between these two will be the absorbed light, right? So what is that? I naught, because it is higher than this I. So I naught minus I, amount of light is absorbed by the sample, but it asks us the relative intensity. So I naught minus I divided by I relative to this incident light. So I naught minus I upon I naught, and if I want to calculate it in percents, then I should multiply it with by 100. So the relative amount of light absorbed will be calculated in this manner. I naught is 100, I is 1, divided by the relative intensity term I naught. So here is 100 again, and I will get 99. So if I multiply it, I will get 99 upon 100 here. After solving this, I will get 99 upon 100, right? And if I multiply it by 100, then I will get 99%. So here I have written this 99%. If it asks how much light is transmitted, so the light transmitted is 1%, because I is 1, I upon 100, I upon I naught. So I upon I naught will be what? 1 upon 100. And in if I multiply it by 100, then I will get 1%. Okay. Otherwise, if simply we just write 0.99 light absorbed and 0.01 light transmitted. So this is the answer of this question. The next question is, an alpha beta unsaturated ketone of relative molecular mass m, which is written as relative molecular mass is written as mr, right, is equal to 110, has an absorption bandwidth lambda max at 215 nanometer. So this is the lambda max. In my next video, I am going to show you the experiment related to this Beer-Lambert's law, where you will understand this lambda max. What is this lambda max, right? So lambda max at 250 nanometers and epsilon is equal to 10,000. So you just see here, no unit is given. So this is the regular practice that it is not reported in terms of its units, right? A solution of this ketone showed absorbance A is equal to 2.0 with a 1 centimeter cell. Calculate the concentration of the ketone in this solution expressed in grams per liter. Okay, so fine. How I'm going to solve this? So first you just write down the formula of absorbance. You just identify what is given, what is asked. So molecular weight is given. At the first instance, we do not need this molecular formula. Wavelength, do not need this wavelength at this moment. Epsilon, yes, this epsilon is required here. This is required at this place. The this we have to calculate this concentration term. Cell length is given x 1 centimeter, and here is the absorbance which is given equal to 2. So I have absorbance epsilon x and c I have to calculate. So put all the values here. So 2 in place of absorbance, epsilon 10,000 liter per mole per centimeter into, this is the concentration, this is the path length. So centimeter will be cancelled out by this centimeter. Now what is left with you? If you want to calculate this C, this whole part will going to be divided on the left hand side, right? So you will get 2 upon this 10,000. So instead of writing 10,000, I have just simply written 10 raised to the power minus 4. You just see 2 upon 10,000. What you will get? You 2 into 10 raised to the power minus 4. And mole is in the denominator. At this moment, it is liter per mole. So mole will go to upside. It will gives you mole per liter, right? So this is the concentration term here. Now you just want to convert this in, this is mole per liter. If you want to convert it into grams per liter, what you need to do? You need to write this. No need to do this. You just cut it down. So mole, 1 mole of given sample is having mass 110 grams per mole. So here you just write down 2 into 10 raised to the power minus 4 moles per liter into multiply it, its molecular weight 110 grams per mole. 1 mole of this sample is having 110 grams weight. So you just simply put it over here, 110 grams per mole. So mole will be cancelled out by this mole. What you will get on multiplying all this, you will get 2.2 10 raised to the power minus 2 grams in numerator and liters is in denominator, gram per liter. So this is how you can solve it. Now coming to the next question. So here is calculate the molar absorptivity. So molar absorptivity is asked, right? For the solution containing this concentration, millimole per dm cube of the solute. Okay, solute concentration is this. The absorbance of a 1 centimeter cell, path length is given, absorbance is given in terms of this, right? Part B is also given over there, that we will discuss later. So first you put the formula. So A is equal to epsilon Cx. Put the values. A is 1.5. Epsilon we have to calculate. Concentration is given in this. Instead of milli, I just put 10 raised to the power minus 3 moles, right? Mole per liter into 1 centimeter. Now epsilon is equal to 1.5 upon all this, right? 1 upon 5 upon 1 into 10 is minus 3 mole per liter into centimeter. So what you will get? You will get this will go to the numerator part and you will get 1500 liter. Liter is in denominator, so it will go to upside, and mole go to inverse side, and centimeter again go to centimeter inverse. So this is the unit of this epsilon, right? Now in the B part, what has been asked? In the B part, what would be the value of A, absorbance, for a solution of double the concentration? So this is the Beer's law. Absorbance is proportional to concentration. If concentration is doubled, then absorbance will again double, right? So the absorbance is 1.5 in the previous case, and if concentration is doubled, then it will convert it to the 2 into 1.5 is equal to 3.0. So it is doubled. The next numerical problem is here. A solution of benzene in ethanol showed absorbance 1.4 at 255 nanometer. So this is the lambda max, right? Path length is 1 centimeter. Molar absorptivity is given this. This is again unitless. Calculate the concentration of benzene in the solution. So concentration I have to calculate. So simply put the formula here. Put all the values here. 1.4, 204 liter per mole per centimeter into 1 centimeter into concentration we have to find out. If you have any confusion in writing the unit of this, so you can simply go here. Absorbance is unitless, concentration is mole per liter, and x is the centimeter. So all this go in the inverse form, division, right? So epsilon will have liter per mole per centimeter. Okay, so you can do that. So here centimeter will be cancelled out by this centimeter. So what you will get? You will get liter per mole. And if we put C at this side, and all will go into denominator, 1.4 divided by 204, and this mole per liter we will get, because it is in denominator previously. Now it comes in the reverse form. If you find it difficult, you can write me in the comment section and I will elaborate it somewhere else. So here is the C concentration and this mole per liter, and the condition is you have to calculate it in grams per liter. So if instead of this mole you can write 78 grams. Okay, so 78 grams, you just simply put 1.4 upon 204 into, this is mole per liter, and instead of this mole you can write down 78 grams. 1 mole is equal to 78 grams. 78 grams per liter into 1.4 upon 204. After solving this, you will get the grams per mole, this much. Grams per liter. Grams per liter. Okay. So I hope you understand this. These are the few numericals which I have solved on this Beer-Lambert's law. And these are taken from the William Camp book. And if you have any doubt or you have some more numerical problems, then you can write me in the comment section. I will solve some more questions on that topic. If you like this video, please give me a thumbs up. Thank you all. Thanks for watching.